Okay, let's dive straight into this explainer and unpack the massive hype around DeepSeek. If you've been following the tech world at all recently, you've definitely seen the absolute shockwaves this company just sent through the entire industry. We're going to figure out exactly how their V3 and R1 models work, the absolute genius behind their architecture, and really, why this level of intelligence is now so incredibly cheap to produce and run. We absolutely have to start with this staggering number, $5.58 million. This is the shockingly low training cost of DeepSeek V3 that disrupted tech stocks and changed the AI industry literally overnight. Just to put this into perspective, models of a comparable scale from other major players, they have estimated training costs soaring well over $100 million. DeepSeek somehow achieved frontier-level performance for a fraction of the cost. So, here's our roadmap for today. First, the DeepSeek disruption. Second, decoding mixture of experts. Third, memory magic with MLA. Fourth, GPO and aha moments. Fifth, DeepSeek versus ChatGPT. And finally, the future of cheap AI. Let's start with Section 1, the DeepSeek disruption. David versus Goliath. Think about traditional, massive, dense models for a second. They require over $100 million to train, and they place a massive computational load on servers for every single query you run. But then you have DeepSeek. At just under $5.6 million to train, it relies on extreme efficiency and something called sparse activation. It's essentially an incredibly lean, cost-effective challenger that is completely upending the economics of artificial intelligence as we know it. Moving right along to Section 2, decoding mixture of experts, the efficiency secret. The real secret sauce to all this efficiency is a neural network architecture called mixture of experts, or MOE for short. Instead of a dense model where every single parameter is used for every single word, MOE entirely avoids activating the whole model for every prompt. It divides the neural network into specialized clusters, or experts, and uses a router to decide exactly which experts are needed for the specific task at hand. You know, you can think of MOE exactly like a hospital triage system. A dense model is kind of like having every doctor in a massive hospital examine every single patient that walks through the door, from the brain surgeon all the way to the foot doctor. It's wildly inefficient, right? An MOE model, however, is like having a triage nurse. That's your router. Evaluate your symptoms and send you to only the specific specialists you actually need. This saves massive amounts of time, compute power, and, naturally, money. To put that hospital analogy into some hard numbers, out of 671 billion total parameters in DeepSeek v3, the model only activates a tiny 4.8% slice for any given word. That's just 32 billion active parameters. It routes the data to just 8 specific experts, plus one shared expert that acts sort of like a general practitioner seeing every token. So over 95% of the model just sits idle, which saves immense computational power. All right, Section 3, Memory Magic with MLA, compressing the cache. When you chat with an AI, it has to remember what you said earlier. Storing this memory is called the key value, or KV, cache, and in massive models, it eats up RAM incredibly fast. Well, DeepSeek introduced Multi-head Latent Attention, or MLA. This is a brilliant attention mechanism that compresses this memory into a much smaller latent space. Essentially, it shrinks the memory footprint needed to remember previous tokens during a really long conversation. And the real-world impact of that compression is just staggering. If DeepSeek used standard attention mechanisms for a 128,000 token context window, it would require 213.5 gigabytes of memory purely for the cache. But with their MLA innovation, they shrank that requirement all the way down to just 7.6 gigabytes. That is a massive reduction, and it allows them to serve way more concurrent users without needing thousands of extra, ridiculously expensive graphics cards. Moving on to Section 4, GRPO and aha moments, how DeepSeek thinks. How did they get the reasoning so good? The secret is an algorithm called Group Relative Policy Optimization, or GRPO. Now, most models learn by having a separate reward model that basically grades two answers against each other. GRPO skips that separate reward model entirely. Instead, it generates a whole group of solutions, say 4 to 16 different attempts at a problem, and normalizes the rewards within that specific group. It is exactly like grading a classroom of students on a curve. It's simple, it's stable, and it's highly effective. This pure reinforcement learning led to an incredible emergent phenomenon, the aha moment. During training, the models spontaneously learned these 4 distinct steps of self-correction. It makes an initial attempt, recognizes its own errors, adjusts its approach, and then actually explains why the new approach is better. This wasn't explicitly programmed into the model. It naturally emerged as the most efficient way to get a high score under that GRPO algorithm. It's actual reasoning, not just regurgitated memorization. Let's look at Section 5, DeepSeek versus ChatGPT, the showdown. Comparing their core strengths reveals a pretty clear division. While ChatGPT, specifically GPT-4o, is highly versatile with general knowledge and multimodal inputs like images and audio, DeepSeek is an absolute powerhouse for highly structured logical reasoning, complex math, and software debugging. Furthermore, DeepSeek's open-source MIT license allows developers to deeply integrate it into their own systems, whereas ChatGPT remains firmly behind a closed API. And when you look at the economics side by side, the contrast is literally night and day. You're looking at around $15 for a million tokens on GPT-4 compared to roughly 14 to 27 cents for DeepSeek v3. Let that sink in. DeepSeek is offering frontier-level intelligence for an absolute fraction of the cost. This isn't just slightly cheaper. This is a paradigm-shifting price drop that completely changes what is economically viable to build.
Finally, Section 6. The future of cheap AI. Practical applications.
So, if you're actually building with this technology right now, here are the key takeaways to optimize latency and cost. First, route easy, latency-sensitive tasks to the standard chat model, and save the DeepSeek reasoner only for the hard logic puzzles. Also, even though it's cheap, you still pay per token, so aggressively trim unnecessary boilerplate text from your prompts. Utilize context caching to reuse stable documents. And finally, deploy vector databases like Milvus to feed the model only the most relevant chunked data. This shrinks your effective context length before it even hits the model. Ultimately, this is why this explainer matters so much. The era where cutting-edge AI was exclusively reserved for megacorporations with massive budgets, that era is officially over. Small and medium enterprises can now deploy frontier-level logic for automated reporting, deep data analysis, and advanced customer service, completely transforming their operational efficiency. Which leaves us with this final, mind-expanding question to ponder. We just saw a 671 billion parameter model trained for under $6 million. As the mixture of experts architecture improves, as memory compression techniques like MLA advance, and as the sheer cost of intelligence continues to plummet, if $5.58 million buys frontier AI today, what on earth will $500 buy tomorrow? Thanks so much for joining me on this deep dive, and keep learning.